Oh, we're going. Okay, so alrighty. So the next problem we're doing is problem 7.10 in your textbook, which is where we're going to start developing our own pi terms and dimensionless variables. All right. So it reads water sloshes back and forth in a tank as shown in the figure below. They don't really need a figure for this, but I guess if you really just need to visualize it. All right. Frequency of sloshing omega is assumed to be a function of the acceleration of gravity g, average depth of the water h, and the length of the tank L. Develop a suitable set of dimensionless parameters for this problem using g and L as repeating variables. So that's going to be key there. We'll come back to that. So it tells us omega is a function of g, h, and L. This is the notation you're going to want to put at the top of all of these sorts of problems, whatever variable you're looking for, as a function of the variables that it's a function of. This kind of helps you keep stuff organized and everything looks pretty. All right. And the next thing that we'll do, usually I make a little chart for this part. Kind of helps me keep it all organized and that sort of thing. All right, so this part is where we're going to start writing our variables in terms of their dimensions, right? So this top part is the variables. Variables. There you go, spelled it right. And then below that is going to be their dimensions. All right, omega is frequency, and frequency is on a per time basis. So that is just 1 over t. Gravity is an acceleration, so that's length per time squared. H is a length, and L is also a length. All right. So next we need to figure out how many dimensionless variables we need. And we do that by a pretty simple step. We count the number of variables that we have. I call that R. So the number of variables is 1, 2, 3, 4. And then we count the number of dimensions that we're working in. Usually this is 3 because we'll have mass, length, and time. But here all we have is time and length, right? Because length is represented here, here, time is represented here, and here, right? So we're only working in length and time, which means n is 2. And then 4 minus 2 is 2, meaning we need 2 pi terms. Not a bad deal. Next to develop pi terms, we find out what we're going to use as repeating variables. Here it tells us to use g and L are our repeating variables. Repeating variables always have to include all of the dimensions that are shown. So g has time and length, L has length. So those are the repeating variables that we choose here. Usually we'll choose stuff on the right-hand side of this equation here. You can technically use what's over here, but usually since we're looking for a function of omega, it's easiest just to use repeating variables over here. So our first repeating variable, dimensionless variable, pi1, we use one of our non-repeating variables multiplied by our repeating variable to the a times our second repeating variable to the b. And we know this has to be in terms of our two variables to the 0. This is what makes them dimensionless, right? L to the 0, t to the 0. So then we write this side in terms of its dimensions that we noted up here. So t to the negative 1. G is in L per t squared to the a. And then L is in terms of cap L to the b. And this has to be length time. Now what we can do is we can set up a simple set of equations and solve for our a and b. So we first look at our variable L. And we notice that a has one L. So we'll have A, and then B has another L, and that has to be equal to 0. So that's our L. For T, we know that we have a -1 here, just on its own. And then we have T in the denominator, or T squared in the denominator, which means this is -2 times A, and then B, just one B. Or sorry, there's no time in B. Just kidding. And this also is 0. So we got time from these two factors, length from these two factors. And then this is a system of equations that we can use to solve for A, plug A in up here, and then we get B. A equals -1/2, B is 1/2. This is pretty simple algebra, but that's also why this is where I made the most mistakes when I was going through this class. Because I looked at this, I was like, oh, I know how this works. A is going to be 2, and then B is also going to be 2, right? But I just make dumb algebra mistakes in my head. So be patient with this part. Since it's easy, there's no reason to make a mistake in it like I used to do. So we have our A, we have our B. So that means we have our first pi term. Omega times G to the -1/2 L to the 1/2. If we're going to write that nice and pretty, we can say that is omega times L over G. So we have our first pi term. For our second pi term, pi 2, we take our other variable that's non-repeating, so H, and then G to the A, L to the B, because those are our repeating variables that we're going to use in our pi terms. All right, let me figure out how to slide this up real quick. That'll work. All right, so we have H, G to the A, L to the B. Same as before, this has to be dimensionless. So we get that it's L times L over T squared to the A times L to the B. Now, before we even do the algebra write stuff out, we notice that T is going to be alone, so we can kind of assume that A is going to be 0, and that it's just going to have to be H over L, because they share the same dimension up here. So if you divide one by the other, you're going to get a dimensionless variable. But just for sake of example, we're going to show, we're going to be explicit and just write it all out. So for L, we have 1 plus A plus B equals 0. And then for T, we have -2A equals 0. A is 0, B then has to be -1. You can kind of tell that intuitively if you want, but if you don't, here's the algebra. So pi over 2 is then just H over L. So now we're going to get, so the way to write our final notation is we do this here. Pi over 1 is a function of pi over 2, meaning however you scale pi over 1, it's going to affect how you scale pi over 2, or not pi over 2, pi 2. And we'll see that once we start solving model problems. This is the meat and bones of what we're going to do for this chapter, though. So taking our pi 1, which is omega L over G square root, that is a function of our second pi term, H over L. And there is your answer. So that's the introduction to Buckingham pi terms. Hope these videos have been helpful. We'll continue to work on improving SI sessions and how we're going to format these as we go on. But yeah, hit me with any feedback. I don't know, like and subscribe. Leave comments. Those would be helpful. Um, all right, cool. I will see you in the next session.